Number 29, it wants us to use the quadratic formula to help us solve this. Well, first, you got to get it set equal to 0. So I need to add 10 to both sides of the equation. So I get x squared plus 3x plus 10 equals 0. So I'm looking for the x that's going to make this guy true. Well, quadratic formula is x is equal opposite of b plus or minus square root b squared minus 4ac all over 2a. There we go. Okay, there's the quadratic equation since we have an equal in it. Now, the a value, because we have an a, we have a b, and we have a c, and I always like us to go ahead and calculate the 4ac piece right here. So a is always who's in front of x squared. In this case, it's a 1. B is whoever is in front of x, 3. And then that piece right there, constant, is 10. Okay. 4 times A times C. 4 times 1 is 4 times 10, 40. Okay. So we got a 40 there. Now, what do I do? Well, just plug them in. Opposite of B, opposite of 3, plus or minus square root b squared. 3 squared is how much? 9. I can do that. Minus, we already did 4ac, 40. All over 2 times 1, which is 2. Now, at this point, I'm basically done. How do I know that? I got to do all this stuff. No, I don't, because here's what happens. -3 plus or minus square root. 9 minus 40 is -31 over 2. Can you take the square root of -31? No, it's an imaginary number. And for this, I said we're going to deal with just real number solutions. So I don't want any imaginary number solutions. We could bring it out and change this. Oh, it's a -3 plus or minus I root 31 over 2, and then break it. I don't want that. Once it's a negative, I'm simply going to say, hey, there's no real number solutions. So you can just say, hey, no solutions here because we got a negative underneath the square root. That discriminant value was negative. That tells us there's no solutions to the problem. They're imaginary solutions, but we're not going to worry about that at this point.